Hey, welcome to Algebra 2. Today we're going to be talking about summation notation. So much of our work in this unit will concern adding the terms of a sequence. In order to specify this addition or summarize it, we introduce a new notation known as summation or sigma notation. This is a capital sigma, this funny looking E, and it represents sums. All right, so we'll use this basically as we go into statistics and into further math classes. So it's a really good idea to just touch on it. I don't want to spend an awful lot of time on it. So basically what it means is if you have something with an index, so this is called an index. A lot of times we call it I, but it can be, different letters. You could have a K in there or even an X. So this just means from A until N. So something like I is equal to 3 to 8 would mean I go, so it's like a loop. So like I starts at 3, goes to 4, 5, 6, 7, and 8. And you're adding each of those terms up as you go. All right, so the index variable is I most of the time, and it ends at that value at the top. So let's look at some examples. I think once you see some of these, you'll know exactly what I'm talking about. So what this means is this is a loop, right? So we have I is 3. So when I is equal to 3, so let's do this. I equals 3, 4, and 5. So just to kind of help us keep ourselves organized. So that means this is going to be 2 times 3. This is going to be 2 times 4. This is going to be 2 times 5. And when you have summation, it means what we're going to do is we're going to add each of those terms. All right, so once you add all them up, we're not going to spend a lot of time with the addition because I'll help you out with that. So the answer to this one is simply 24. So again, with k is equal to negative 1 to 3, which means it's going to be negative 1, 0, 1, 2, and 3. So there's 5 terms of this series, and it's k squared. So it's going to be negative 1 squared plus 0 squared plus 1 squared plus 2 squared plus 3 squared. Add them all up. Again, we're not going to waste time with the addition. 15. So in C, our index begins with negative 2, negative 1, 0, 1, and 2. So when J is negative 2, it's 2 to the negative 2, plus when it's negative 1, 2 to the negative 1, 2 to the 0, 2 to the 1, and 2 to the 2. Add it up, this actually turns out to be a fraction, 31/4, which is equal to 7.75. Now the negative ones, basically when you have negative 1 to a power, all that's going to do is flip-flop the negative ones. Because what this tells me is we're going to get negative 1 to the first power, plus, and I'm going to put in parentheses, plus negative 1 to the second power, plus negative 1 to the third power, and we're going to keep doing this until we get to our last index, which is negative 1 to the fifth power. So to an even power, it's going to be positive, and to an odd power, it's going to be negative. So this is negative 1 plus 1, minus 1, plus 1, minus 1. And when you add them all up somewhere along the lines, they cancel out. So these two cancel, and negative 1 is my final answer here. So getting the hang of it a little bit. So E starts with 0. So with 0, it means it's 2 times 0 plus 1. So there's my first term. With plus 2 times 1 plus 1. I'm going to run out of room, so I'm going to go down here if that's okay. Plus 2 times 2 plus 1. So we add all these up, and we get 1 plus 3 plus 5 is equal to 9. F is a little bit different, but still not horrible. So, and if it helps you to do the 1, 2, and 3, feel free to, whatever helps you. So this is going to be 1 times 1 plus 1, which is 2, plus 2 times 2 plus 1, which is 3, plus 3 times 3 plus 1, which is 4. So this one turns out to be 20. All right, exercise 2 is just a multiple choice question, but basically asking exactly the same thing that we've been doing. So this says from 1 to 4, and again, if it helps you, 1, 2, 3, 4 are our indexes. So we have 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And don't flip out because you can put these right into your calculator using your fraction bar. And I'm not sure what the answer is. Let's see. So just quickly, what that means is I just found a common denominator. You guys can do it in your calculators. But 12 over 12 plus 6 over 12, which is equivalent to 1/2. 4 over 12, which is equivalent to 1/3. 3 over 12, which is equivalent to 1/4. Add the numerators up, and we get 25 over 12 being our answer. All right, moving on. Exercise 3. Consider the sequence defined recursively, all right, by a sub n is equal to a sub n minus 1. So a sub n is equal to the previous term plus 2 times the term before that. And in this case, they have to give us both terms at the beginning to find the third term. So they give us this, they give us this. Again, make sense of it. So this is the term I'm looking for, is equal to the previous term plus 2 times the term before that. So the previous term before that, or the term before that. All right, so that's what that means. So now notice they're giving this, they're telling us to add these things up. So what they're saying here very nicely is they're giving us a sequence, and they're telling us this basically means to add the fourth term through the seventh term. So all we're going to do here is we're going to figure out what the terms are. We have first term, second term, third term, fourth term, fifth term, sixth term, seventh term. So first term they give us, that's 0. The next term is 1. Now, the third term is going to be the previous term, which is 1, plus 2 times the term before that, which is 0. So the third term is going to be 1. The fourth term is the previous term, which is 1, plus 2 times the term before that, which is also 1. So this is going to be 3 plus 2 plus 1 is 3. The fifth term is going to be the previous term, which is 3, plus 2 times the term before that, which is 1. So this one's going to be 5. The sixth term is the previous term, which is 5, plus 2 times the term before that, which is 3. So this term is going to be 11. And the seventh term is going to be the previous term plus 2 times the term before that, which is 11 plus 10, which is 21. All right, so here are my terms. This one, this one, this one, this one, and this one. And we're simply just going to add them all up. So it's only, remember, it's only the fourth one. So it's only from, so this one, this one, this one, and this one we add up to get 40. Do we get 40? Because it's only the fourth to the seventh term. The fourth to the seventh term. So 3 and 8, 19. Yeah, it is 40. Good. I had 40 written down, but it didn't look like 40 to me. Okay, so now we're going to kind of work backwards with exercise 4. Now I'm giving you the sequence, or the series actually. I'm giving you the series, and I want you to try to figure it out in sigma notation. And sometimes this can be a little tricky. So the first one isn't too bad. We're looking at 9, 16, 25 perfect squares. So this isn't too bad. So we're going to call our index I. So I is going to go from, because this is 3 squared, 4 squared, 5 squared, up to 10 squared, we're going to let I go from 3 to 10, and it's simply going to be I squared. And that will generate that sequence that you see right there. All right, when I look at B, and you just have to make sense of it a little bit, you see how they're all multiples of 3? So this is 3 times negative 2, this is 3 times negative 1, this is 3 times 0, this is 3 times positive 1, straight up through 3 times 5. So when I write this one down, I'm going to let I go from negative 2 to 5, because that's what makes sense to me, and it's just simply going to be 3I, and that will generate that sequence. All right, so in C, I'm hoping you're recognizing that these are multiples of 5. So this is going to be 5 to the negative 2, to the negative 1, to the 0 power, to the first power, all the way up to, this is the fourth power. 5 to the fourth power is 625. So in this case, I'm going to let my index go from negative 2 to 4, and it's simply going to be I squared again. Oh, no, duh, 5 to the I. 5 to the I. I'm thinking squared here. Right? 5 to the negative 2, 5 to the negative 1, 5 to the 0, 5 to the 1. I'm sorry about the constant interruptions, but anyway. Exercise 5. Which of the following represents this sum? So let's see how I thought about doing this. I think I started saying to myself, well, they look like they're multiples of 3. That might work. But then sometimes I think the easiest thing to do is say, let's see, I add 3 here, and then I added 6 here, and then I added 12 here, and then I added 24 here. So you start seeing the pattern. And I'd like you to do me a favor and pause it and see if you can figure out which one this is. Because there's a couple of different ways that you can do this. You have 4 possibilities here. So you can generate each one of these 4 problems and see which one this is equal to. I say a lot. I'm sorry about that. The second way you can do it is actually try to make sense of it. So either way, pause the video right now and see if you can come up with the summation notation that represents the series. Well, hopefully you came up with number 2. 2 is the one that works. All right, when it's multiple choice, if you have difficulty with trying to figure it out on your own, then go to the choice answers and let them help you. All right, last problem, exercise 6. And this is kind of fun. And it's one of those things where you actually have to write it out before you understand it. So when you take a look at this, which looks a little scary, but once again, just start generating it. Don't let yourself get crazy. So what this means is when, let's go like this, 1, 2, 3. Let's give us some ideas of what these look like. So when I is 1, we get 1 over 1 minus 1 over 2. The second term is 1 over 2 minus 1 over 3. Now remember, in between here, we're adding these. All right, so the third term is going to be 1 over 3. I'm sorry, not plus. It's a minus sign. Minus 1 over 4. And when you get towards the end, you get 1 over 98 plus 1 over 99, and then you get minus 1 over 99 plus 1 over 100. This is the plus that adds the two terms together. All right, so what you realize here when you put these all together, this is called a telescoping series. It's kind of cool, right? But what happens is when you regroup these, what happens is that a minus sign? That should be a minus sign. All right, when you regroup these, they cancel out. The middle terms cancel out. So at the end, we're left with this 1 at the beginning and this 1 over 100 at the end.
Can I add this student?
Okay, just coming to the point where I cannot do this at the end of the day. But anyway, so this is just equal to 99 over 100. So I thought it was pretty cool. I like that question. All right, so we kept this one short today. It's only 16 minutes long. So like I always tell you, just go out there and make good choices every day, be kind to each other, and we'll see you next time.